Good morning, everyone. This is Ahmed Ghadban, a senior engineering software developer at AEDA LLC. And today I'm going to be briefly discussing one of our softwares, namely FRP beam section strengthening analysis. This software is basically designed to analyze cross sections of reinforced beams that are strengthened with FRP for both flexure and shear as well. Getting right into it, I'm going to open the user interface of the software and then discuss some of its features. Under the File tab, you will be able to save your project or open a saved project, which gives you the flexibility of starting a project and then continuing it later on if you want. Or you can save multiple projects and compare the results later on. There is an easy toggle between the US units and the SI units, as you can see. So if you start one of your projects in a certain unit and then you decide halfway through that you want to switch the units, you can easily toggle this radio button and all of the inputs will be automatically converted to the desired unit. As you can see, the user interface is divided into several sections, each with unique color that houses certain inputs or outputs or processing buttons for specific things. So if you look at the red section, it's specifically targeting material properties. And this section is divided into three subsections, one for the concrete, one for the steel, and one for the FRP. So in the concrete subsection, you can define the compressive strength, the modulus of elasticity, the modification factor if you want to analyze lightweight concrete. Then you have the concrete strains that are required to model the stress-strain behavior of the concrete, which is modeled in the analysis following the Hogenstadt parabola. And then in the steel subsection, you can define the yield strength, the modulus of elasticity for both the longitudinal steel and the transverse steel as well. Under the FRP section, you can toggle between the longitudinal FRP and the transverse FRP using this radio button. And then for each, you can define the properties of the FRP. So you can choose, or you can choose a built-in properties, as you can see from the list over here. So if you choose any property, it populates with the modulus of elasticity and the ultimate rupture strain and material type, exposure. You can choose the exposure condition as well. So this is for the material properties. If you move to the blue section over here, it's targeting the geometric properties. The first subsection at the top here deals with the geometry of the cross-section. And our software allows for 5 different cross-sections. So you can have a rectangular section, a T-beam, an inverted L shape, you can have an inverted T, an L shape as well. And these the last two sections are meant to analyze negative moments, if you wish. So for each of these sections, you can define the width, the height, and the other features of the sections. And as you can see, if you choose a T shape or an inverted L or inverted T or L shape, all of these, you have the option of making them tapered, like having a tapered whip. So you have an input for the initial whip width, which is over here, and then an input for the final whip width, which is at the bottom. So if these two values are the same, then your section is not tapered. But if you choose to taper your section, you can have a BW0 that's larger than BW1. This will be a tapered section. So that's an additional features that was added later on in our software. Now the other subsection over here deals with the steel properties. So basically, or the dimensions of the steel rebars or the depth of the steel layers and so on and so forth. So you choose the number of bars, the diameter of the bar or the size of the bar, and then the depth. Then you're allowed to have up to 3 layers of tensile steel and then 1 layer of compressive steel. Then here you have you can define the tie bars, the diameter and the spacing You have the option of having only one shear leg if your web is very narrow, or you also have the option of having extra shear legs, not just two. You can have 3 or 4 if you have a wide cross section. And then the last subsection over here deals with the FRP, and you can toggle between transverse and longitudinal FRP. You have the option of using sheets or plates, or some bars or tapes as well. Of course, here, because we're using a built-in material, but if you use user specified, you can switch between sheets and SM bars. And then for each of them, you have the corresponding inputs. For the soffit strain at strengthening, you have the option of having the software calculated for you, and it's basically calculated based on the moments you provide over here. Or you can provide the strain yourself if you choose to do so. The transfer FRP, you have the option of having a two sides wrap like this, or a U wrap, or a fully wrap, which is only allowed if you have a rectangular cross section. So that's can fully wrap the cross section if it's rectangular. Then you provide all the inputs associated with this kind of like with the transverse FRP, and then you can also have the option of having a 40-degree wrap like this. So if you remove this checkbox, you're using a 90-degree. If you check it, you're using the 45-degree, and then you can define the spacing, the width of each wrap, and so on and so forth. Now, the green section over here deals with the loadings, the service moments, and the shear inputs. So you can have a dead load, construction live load, upgrade live load, and the ultimate shear. And then these things, you can have them, they are calculated using the ACI default. As you can see over here, you have the option of having sustained live load if you want. You can check this box. And then the next section, the white section over here, is for processing or analyzing. So you have buttons, you have the cross section. So if you submit your inputs, well, obviously I don't have the geometry defined over here. So I'm gonna use a saved file to show you. The software is equipped with some warning and error features that capture certain warnings in accordance with that do not follow the ACI recommendations, or it gives you an error if there's something that hinders the analysis process as well. So and then once you submit the inputs, you have your cross section drawn over here for you to scale, and then you can clear the inputs if you want to start a new project. And then you have the option of saving a screenshot of this user interface. I mean, you might choose to do so if that's convenient for you to save your inputs. Or otherwise, you can also save using this button over here. You can save it as a text file. So, and here you run your analysis using the analysis button. You get a pop-up window that shows you the failure mode. So this is a failure mode that's debonding of FRP, and you can see in this figure that the FRP is debonding. And then we move to the last section, which is the results section in gray over here, which houses all the results, and then it tells you if your service stresses passes or fail, and if your ultimate moment, ultimate shear pass or fail as well. So it gives you this output, and then all the numbers, the general, like the summary of the results. Then if you want to get a more detailed report, you can use this report button here. This one will generate a PDF file which you can open. Yes. So it generates the AEDA LLC, the date, gives you some some case name, which is the project name or the file name, and then gives you the inputs, your sectional parameters, material properties, the loading inputs, moment and shear. Then it gives you some equations that gives you an idea about how the analysis is being conducted for the flexure, for the serviceability, and for the shear as well. And then it gives you the summary of the results, and then some additional results that are not shown on the user interface. Some results for the shear, and then these last tables is to inform you whether you've passed all the limit states or not. So this is a nice little report that can be used to save the results for your project. Now, I'm going to move on to just give you an example that we ran using software, which is example 16.3 in ACI 440.2. And this saved file that I actually opened just now is actually for. So these results, we can pull up some data and compare them to the results in the ACI example. And as you can see, the soft strain is exactly the same. The debonding strain, ACI rounded it to 0.009, so it's pretty much the same. The depth of the neutral axis is quite similar, 5.17, 5.18 in our software. And then the design flexure strength, 327 in the ACI, 327.54 in our software. So that's very good agreement that we got using our software, giving us like obviously we tested the software with other examples as well, but this is just one of them just to show you that it does give accurate results. And I actually forgot about mentioning one other important feature, which is this button over here, which is optimize design. So this button, instead of analyzing your cross section with the specific inputs that you put it over here, the option whereby the software can tell you what's an even better input for you, or like a better design for you. So say, for example, you want to design for flexure and shear. Then you input then you can design for strength or strength and serviceability as well. So if I choose to design for strength, I can specify my ultimate moment. It can be the same as this one. You're gonna leave it the same. Then you design. It gives you a figure. This is your ultimate moment. And then you want to make sure your design moment is above it. So anywhere above this black line is safe, below this black line is failure. And it gives you exactly where you meet your ultimate moment, applied moment, which is at NF equals 0.77. So that's NF equals 0.77, which is right over here. So that's where you are meeting the demand moment. Now, the ACI example provides 2 plies, but that's too much. Even 1 ply is enough, and even less than 1 ply. You can have a ply that's not across the entire width of the cross section, and that's only 77% of the width of the cross section. That will be sufficient to resist the applied moment. And then you can also have a tabulated data over here, where for each NF, it's basically the same as this figure, but it's in tabulated form. You can get the failure mode. So if you choose 0.77 somewhere here, that's going to have a rupture of FRP failure mode. Maybe you don't want this kind of failure mode. You can choose to go to concrete crushing or debonding. So it gives you some more data if you open the tabulated, if you press the tabulated button over here. Then you can print this graph if you want in PDF form. And if you exit this, it opens up the shear, the window for the shear optimized design. You can specify your ultimate shear, and then design, and then it gives you, this is the ultimate shear. This is the maximum shear the section can achieve. So no matter how much FRP you provide, you will not be able to exceed this this value over here. That's according to ACI. Then for different values of NF, you have different curves. Now, as you can see here, even the unstrengthened section is well beyond this ultimate shear, because all of these graphs are above this ultimate shear value. And with this, I conclude the brief discussion of this software. We do have other softwares as well for sale, which is the FRP column confinement analysis software, and there's the FRP residential wall designer, which is not really a repair software. It's more of a like internal FRP rebars. I mean, it's walls reinforced with internal FRP, not external FRP. Please do feel free to contact us for additional info you want. This is our website, our email address, or if you want to reach our one of these phone numbers as well. And thank you for your attention.